Frame analysis. Video 9. Steel design according to first order theory, part 3. We now want to perform the actions required to obtain an acceptable structure. We saw earlier that beams 9 and 10 and columns 5 are overutilized. Of these, member 9 has the highest utility. In the section value window, we see that the section ends up in section class 1, which means that the plastic section values may be used. If you look at the code check, for this member we see that the maximum stress check is 1.34, the shear check is okay, 0.41, and the lateral torsional buckling check has the highest utilization, 2.52. All ultimate limit state checks will in this case of course result from load case US, as we just had one ultimate load case in this example. Furthermore, we see that the deflection for load case SLX exceeds the given criteria L divided with 300. The maximum stress check and the deflection requires a larger section, while the lateral torsional buckling check can be affected by defining lateral supports. In the code check window, it is possible to quickly find out which section is required. However, this is only a preliminary check, because when the stiffness is changed, it is of course also necessary to perform a new analysis. We see that an increase from HEB 200 to HEB 240 is sufficient for the stress check. When it comes to the deflection check, we have to perform a new analysis. When leaving the window, we are informed that the section is restored to the original. We then choose to change all the beams 3, 6, 9 and 10 to section HEB 240. We then return to program part input in geometry and choose section and define a section HEB 240 and link it to section group 1. Then we perform a new analysis and a new design. A new check for member 9 now shows that all checks except the lateral torsional buckling check are okay. A look in the capacity window shows that the critical lateral torsional buckling moment is 296 kN and the reduction factor 0.59, which means that 41% of the moment capacity is lost due to lateral torsional buckling. The moment capacity is 204.5 kN. It is the support moment of 325 kN that is the problem, meaning compression at the member's bottom flange. We try to define a continuous lateral support at the bottom level for member 9. By activating the option lateral support, the defined support can be shown graphically by a magenta colored line at the bottom of the member. A new calculation now shows that the capacity for member 9 is sufficient. In the capacity window, we can see that the lateral torsional buckling factor increased from 0.59 to 0.65, and in the code check window can be seen that the lateral torsional buckling capacity is clearly below 1.0. It is not only the capacity that has increased, because the bottom flange is supported, it is now the span moment, producing compression at the top flange that is used in the check instead of the larger support moment. We also see that the change to a HEB 240 made the capacity sufficient also for member 10, where the capacity earlier was inadequate.